Hello, everybody. Welcome. Thanks for joining us today. Well, before we begin, our workshop. Oh, whoa, whoa, whoa. Excuse me. All right. Okay. So before we begin our workshop, I want to make sure that you can hear and see me clearly. Well, if you can, drop a plus, a plus into the chat. Well, and if you don't, drop a minus. Well, I'll give you a moment for everyone to respond. So, guys, please feel free to let me know whether or not you can hear and see me. Oh, great. I see lots of pluses here. So, uh, if you want to drop a minus, you better check your software and hardware if it works functionality. So, welcome to our workshop titled Amazon ECS Anywhere Building a Stretched Architecture Across On Premises and AWS. I'm Sergey Konstantinov, and I'm glad to be your speaker today. And I'm a systems administrator and engineer at EPAM with extensive experience in designing and implementing cloud and on premise solutions. So, this workshop is brought to you by the collaborative efforts of our school, AWS, and EPAM, and we're really grateful for their collaboration and commitment to advanced cloud technology education. So, before we dive into our workshop, let me go ahead and copy and paste the link to our workshop. Just a second, guys. I'll drop it into the chat. All right. So, guys, let me know if you see the link, if it's clickable, and if it is, just go ahead and click on it without any hesitation. So, about our workshop, how to get started. We're going to be starting it like as an AWS event. And you make sure that you have access to this workshop because you probably filled out a Google form and you most likely stated your email there. So, in order to join our workshop, we need your email there. So, to do that, as soon as you click the link, this window will be open uh, in your browser. So go ahead and click on this, orange, bright orange button, and you will be prompted for your email address. And you go ahead and, put it there and receive a one-time password to your email. Then you provide it to the field. Click OK. Then this event access code will be asked, but the access code is already embedded into the link. So all we have to do is just to wait until this next button is gets active, and just go ahead and click on the next button, and you're good to go next. So guys, uh, if you are already joining our workshop, just let me know. If you're able to do that, drop a plus into the chat if you're able to join our workshop, if your link is working and you're receiving your one-time password and so forth and so on. So don't be shy, let us know. Then you click on agree with the terms and conditions, and I'll click on join event. This is pretty easy. All right. Great, guys. Nice to see your pluses here in the chat. That means that our accounts are working and functional, which is great. And there's one reminder, guys. This workshop will last for probably 2 hours. And after our live event finishes, all the accounts will be almost immediately terminated. So, guys, be aware of that. And well, what do we do next? We got to go ahead and open AWS console and make sure that your region is like mine, EU Central 1. go ahead and open it. Okay, in a new tab. Yeah. Next, you got to go ahead and type in the search field and type Cloud9. We need an ID uh, in our event, so in our workshop. So go ahead and do just like me. Oops, excuse me, wrong language. Cloud9. All right, got to go ahead and open in the new tab. All right, let's see what we got here. And then we gotta, if you have a screen like this one, press click on the hamburger, then share it with me. And there you have your environment already shared with you. Click on open and a new tab. And probably will have to wait a little bit of time until your IDE is up and running. Yeah, here it is. We have it. Oh, so Pavel, what's the problem with you? I mean, what seems to be the problem? And just let us know in the chat so we could help you. All right. What I can do is just to split my screens here, so we could do in both two panes, like the workshop pane and the terminal. So now I'm waiting for you guys to get access to your IDE. As soon as you done with that, we can go on. Mhm. You don't remember which email you used when you got registered, Pavel? So, okay. So, what are the objectives of our workshop for this one? So, here is what we got to do. We got to understand the capabilities and benefits of our Amazon ECS Anywhere. We got to learn how to configure and deploy ECS Anywhere in a hybrid environment. And then we gain hands on experience in building a stretch architecture that leverages both on premises and AWS resources. And by the end of this workshop, well, I think you should feel pretty confident in using ECS Anywhere to extend your containerized application across different environments. So the Google form, that is strange. Okay. So guys, please drop a plus into the chat if you have spun up your IDE, your Cloud9 environment, and we will go from there. And there are two ways that you can go through this workshop. You can do it at your own pace. Maybe you're pretty advanced and you like doing all by yourself, or there's another option. You can do it like step by step and follow it with me. So it's up to you. But remember, limited. We're limited by time. So I'm just waiting for a couple of pluses that everybody's started their IDE, and we can go from there. Uh, while we're waiting, you can go ahead and overview of this workshop. This is introduction. There are some use cases of ECS Anywhere. It's kind of a modernization, hybrid environment, and IoT, and well, lots of stuffs. There are some, design considerations and supported platforms. You can familiarize yourself with them, like AWS Wavelength, local zones, AWS regions, and well, if you're interested as well. You can take a look at customers frequently asked questions and see what's there. Well, actually, there are some interesting of them, but as I can see, we can go now. All right. So here in the workshop, we have through three modules: module 0, module 1, and module 2. We're going to be doing two of them because this workshop is pretty extensive and long, and module 2 could turn out to be pretty um wow. Are you sure? Gays, not guys. All right. And it may be pretty pretty hard for some of you. So we'll be doing two modules. The first one, module 0, will be creating an AC2 ECS cluster, and our module 1 will be building a stretched architecture across AWS and on premises. All right, and here on my left pane, okay, let's close this one, and maybe I can make my font now it's bigger. And what about this? Okay, we can go ahead up on the terminal here, and probably we can uh, make our font bit bigger. No, we can't. For some reason, I can't. All right. So here you can see a ECS cluster. What we'll be creating is in this module, the ECS container service. So what is that? Maybe some of you don't know what it is, and I'm going to give you a little bit of an explanation. So ECS is a service that helps you to run and manage containers. Containers, you can like small portable packages of software that include everything needed to run an application, such as code, runtime, system tools, and libraries. And think of containers as lightweight, self-contained environments for your application. And well, ECS organizes containers into groups that are called clusters, which we're going to be creating right now. And a cluster is like a big container warehouse. And when you define what each container should do, we use task definitions. And then you can run these tasks and services. It's like specifying the job for each container and then making sure that it keeps doing this job. All right. Hopefully everything is okay, guys. All right. Let's move on. So, our prerequisites. First of all, we got to go ahead and get the code of our workshop. Let's do that. Copy and paste. All right. Let's double check that we got this. Yes, there's a hybrid container stuff here. Good. All right. Uh, okay. Now we got to check and make sure that Copilot is installed in our IDE. What is that Copilot, you may ask? And please don't confuse this with GitHub Copilot, because this is completely different. This is not an AI like assistant for coding. This is a very different tool. And for doing that, just go ahead and Copilot version. Yeah, here you go. We have it installed. But if, well, I'm not sure, which I really doubt, if you some cases you don't have it, just go ahead and copy these commands and paste it here and install Copilot into your ID. Excuse me. So maybe some of you don't know what Copilot is. I mean, AWS Copilot. So AWS Copilot is a command line tool that helps you easily deploy, manage, and operate containerized application and on AWS. It's like having a personal assistant, but not a coding assistant, but assistant that guides you through setting up and running your containers. As well, it follows AWS best practices for security, scalability, and reliability. So you don't you don't have to worry about making mistakes. All right. Okay, let's go next. So, this step number one, using Copilot, we're going to create our ECS cluster. And here's the command that we will be running. But what it is, it says Copilot app in it order. So we're going to be um, initializing an application. So, what is an application in terms of Copilot? Well, an application is a collection of services that work together to perform a task or set of tasks that, well, think of it as overall project or solution you're building within an application. You can have multiple services like front end service, some back end service, or maybe database service. All right. So, what does this command do? This command will create the Amazon ECS cluster and base networking to support components that will be deployed in our AWS. It will be our orders API application. So, go ahead, copy the command and put it into the terminal, paste, and there you go. There is going some process. All right. Uh, we can take a look what expected output is going to be. All right. It probably will take some time. And as you can see, it creates a role, etc., etc. Well, if we want to see what's going on behind the scenes, we can visit our console, navigate to our search field, and type cloud formation. Actually, our Copilot CLI tool is something kind of a infrastructure as code tool, which creates infrastructure for us. So we can see our cloud formation stacks, and all of them are already in create complete status. So let's take a look at our console. Yes, there it is. It is completed. So what do we do next? So next, we're going to be creating an environment, as we can see, Copilot and init. And then we will specify a flag like containers inside. So we could be monitoring what's going on inside the container, and there that we give it a name development, and the profile that we will be using is just the default profile. You probably got to know what profile it is if you uh, if you are familiar with that. So go ahead, copy this one, paste into your terminal. Then what should we say? We should say yes, use default. Just go ahead and press enter, and your environment will be initializing. Again, we can navigate our cloud formation stack. We go ahead and like refresh it, and there you go. So now we're creating an environment in terms of Copilot, AWS Copilot. So what it is, an environment is where kind of a place where you run your application. It's a combination of AWS resources configured to support your application. You can have multiple environments such as development, testing, and production, and maybe you can UAT and staging, whatever. Each environment is isolated from others, allowing you to test changes safely before deploying them to production. When you create an environment, AWS Pilot sets up all the necessary infrastructure for you. This may include things like VPCs, subnets, and load balancers. So the environment ensures that your service have everything they need to run so pretty smoothly. So we see here our cloud formation stack is still running, and while it is still running, uh, again, maybe some of you still don't know what cloud formation is. And cloud formation is a service that helps you model and set up your AWS resources. Oh, All right, we're finished, but let me, uh, yeah. So since we have deployed our environment, I mean, we have created our environment. Now we're going to deploy our environment. And to do that, we copy and paste this command and run it. So another cloud formation stack will be created, and I'll continue about the cloud formation. So a stack. A stack is a collection of AWS resources that you can manage in a single unit. Think of it like a blueprint for your cloud infrastructure. You define what resources you need, like services, databases, and networking. Well, in one template file, well, maybe not in one actually, but in a template file. When you create a stack, CloudFormation reads this template and sets up all the resources for you. So this makes it pretty easy to create, update, delete a group of resources altogether. So, okay. So it's kind of our final step here of creating an ECS cluster. Guys, just let me know if you have successfully created this. And if you have, drop a plus into the chat. Now I know that this module number 0 is almost over. Okay, still we are waiting for our cloud cluster to be provisioned. So here with me, it's already done, and I can go ahead and check it. So we can go to our AWS console and try to find ECS, Elastic Container Service. Really? All right. So go ahead and open the tab, and the cluster might be there. Oh, there it is. Here's our cluster with enabled container insights. Pretty good. All right. Oh, I can see pluses that you probably guys have already provisioned your ECS cluster. Great. And our last step in module number 0 is to export ECS cluster's name. To do that, we just go ahead and run this command, and we put the cluster name into our bash rc file. And it's just because if we want to open a new terminal like this, so the cluster name will still be there, like this. Uh, let me try like this. Echo the cluster name, and there you go. So your cluster name will be like distributed across all your terminals in your IDE. So, uh, our next module probably, right? So, guys, keep dropping your pluses if you have finished with creating your ECS cluster. I think this is kind of a pretty easy step, pretty easy module that we have just done here. And let's go next. So we're getting to module number 1, and we can take a look at the diagram here. And here, what we'll be creating in this module, we will deploy a sample workload stretched across on-premises and AWS. Oh, I can see pluses. That's great. All right. And the workload will be consisting of an orders API and orders processor deployed on-prem due to the, let's say, data requirements. This hybrid setup allows customers to benefit from AWS, availability, cost optimization, and resilience while processing orders on-prem. Okay. So here's our diagram, and let's go to deploy our API orders application. Again, we will be using our favorite Copilot, and when we'll initialize another application, will be called orders. So let's go ahead, copy the command, and paste it into your terminal. All right. Let me clear the screen and paste the command over here. All right. The command has started working. Again, we can go ahead and verify in our cloud formation pane. And all right. Oh, it's already done, but as you can see, we should select no here. Go ahead and just press enter. There we go. So now we'll be creating add-ons, not as additions. This addition will be an SQS service, and we'll be using like SQS queue URL. To do that, we'll need to create an add-ons directory. We can quickly do that. Here we go. And now we will be creating, mm, actually, it's a template file for CloudFormation. And here it'll take some parameters like app environment and name. It will create resources. It will create the queue and will apply AWS managed policy for queue access. And the final like section is output. It will output SQS queue URL and queue policy ARN. ARN is an Amazon resource name, just for you if you, in some case, you don't know. Okay, what we do is just we copy, paste into the terminal. All right, and here we go. We have created this file called uh, QYML. That's a YAML file. Now, next step, we're going to update our Copilot application manifest file, and we can take a look at the application. It will be orders API, type load balanced, and the traffic will be distributed like here. So we have just root, and the path of health is this one. This is just health check that we're going to be doing. And the image that is going to be built, it'll be taken from this directory orders API. Okay, maybe we can take a look at this here. Let me do it. Hybrid containers, then orders API, and here goes the Docker file. You can just go ahead and familiarize yourself with this Docker file if you're interested. So this Docker file will be taken from this directory and built and then pushed to the repository. So now let's go ahead and deploy it. All right. Let's just close this panel. All right. Copy, paste, and go ahead. Okay, we can see that our containers is being built now. And yeah, it's extracting. Uh, I always forget how they're called. All right. Now let's wait for container to get built, and then it will be pushed to the repository. So while it's deploying, we can take a look at our next step. This step is for improving security and compliance and so forth and so on. Yeah, now we're already pushing our image into the ECS. Well, while it's pushing, let me say just a couple of words about this SQS add-on that we are creating. And maybe maybe you don't know much about SQS, so this is a brief introduction. So SQS, it's a service, as you might know, and it allows you to decouple and scale microservices, distributed systems, and serverless applications. And an SQS queue is a place where messages are stored and processed. So think of it as a line of where tasks they wait to be handled. All right. What do we have here? So we're still creating. So we were talking about this step to improve like our security. And here you can see that we can go ahead and take IP address of our Cloud9 EC2 instance and then find the load balancer and then find the security group which is attached to this load balancer. And instead of the default 4 zeros that is from everywhere from the internet, we just copy and paste there the IP address of our Cloud 9 EC2 instance. This is like a recommended step, and you'll really enjoy the security. Just go ahead and do that. All right. And let's go next. We can go next. I mean, I can't so far because I'm still waiting for the cloud formation uh, stack to be finished. So as you can see, we have a couple of a couple of stacks here being created, and we can go ahead and let's say dive into one and see what's going on in here. We can see events, something is created, something is in progress. We can see resources that are being created. We have, as you can see, a cluster and elastic load balancing target group. Also, we can take a look at the outputs here. So there's a lot of information. And well, in case something goes wrong, you can go ahead here and uh, just check what's going on here, what's wrong. And well, pretty often, like errors are pretty self-explanatory, so you can easily understand what's going wrong here. All right. So as you can see, we're still in progress, which is great. So that means so far no mistakes here. All right. So now we're still waiting. Okay. And by the way, also we can go ahead and check our repository here, ECR. So that's Elastic Container Registry, right? All right. Elastic Container Registry in here. Excuse me. We can find our repositories. And there it is. We have our latest image already uh, uploaded, already pushed to our uh, registry here. All right. Well, it takes pretty much time. All right. Okay. Well, maybe as an intermediate step, you can drop a plus into the chat if you if you have successfully pushed your image into the container repository. All right. Okay. Maybe. Yeah, and again, you'll have security. And please let us know if you were able to improve security restrictions and you were able to restrict access to your load balancer and entered an IP address of your EC2 instance, of your Cloud 9 EC2 instance. Well, if you don't know where to find it, you go ahead to your console, then navigate to, it should be somewhere here probably. Yeah, navigate to EC2. There it is, run an instance, just one. Click on here. And there you go, your IP address. You just go ahead and copy this one, go to load balancers, find the load balancers, go ahead and find like security. That's the security group. You navigate to the security group, and here you go. The source is 4 zeros. You got to go ahead and edit inbound rules. And instead of 4 zeros, place your IP address of your EC2 instance of your uh, Cloud 9. All right. Okay, let me check our stacks. Oh, they're almost done. They're almost done. A little bit left. Resources. Let's see what we have here. We have some functions, roles. What about outputs? Nothing. So now we're currently creating task roles. Okay. Okay. All right. Mm, okay. little bit more left time. Okay. Or stack. Come on, we're waiting for you. Oh, configuration is complete. That's great. Still creating. All right. Okay, after this one's been created, we will just check this application with this Copilot command. So service, show, and orders. All right. Yeah, let me close this one. So let's close the Docker file. This one. No. Okay, go ahead and close it. All right. So load balancers, okay, stacks. So orders API still being provisioned. Oh, no, not going to delete that. Stack info. Yeah, it takes time to create. I think that's why Copilot, I mean AWS Copilot is pretty useful. You didn't have to worry about how you want to configure your infrastructure like VPCs, your like subnets. We can actually take a look at them here. Okay, let me find where okay, let's find VPC here. Excuse me, VPC. Okay, let's go ahead and open our VPC. So all our network infrastructure was created completely by uh, AWS Copilot. As you can see, there's the name of it, as the name of VPC. It like created everything behind scenes. You didn't have even to worry about your CIDR blocks. And here go your subnets. It just created 4 subnets. Actually, we can just take a closer look at the resource map, what it created. It created 4 subnets. 2 of them are private and 2 of them are um, uh, public, and 2 route tables. And I think this is, yeah, this is probably internet gateway, right? Yeah, this is an internet gateway. So all this was created by uh, Copilot, and just didn't have to think about it. It was created for you. So it's called kind of a opinionated tool because it does a lot of stuff for you. Yeah, you just don't have to worry about like load balancers and networks, etc. All right. Mm. Well, let me take a look at here. What do we have? Events. Mm. All right. Due to unhealthy status. Interesting. All right, let's take a look at the uh, ECS cluster. What's going on there? Okay. Oh, there it is. Yeah, we can see that there's a service already running here. And oh, both of our tasks are already running and they're healthy. Looks great. Looks like it were health checks. All right. Load balancer. uh, Okay. Still waiting. The cluster. Okay, the running tasks. All right. So, how are you guys doing? Have you created uh, SQS add-on and updated Copilot application manifest and then successfully deployed it? How are you doing? Just let me know. I need your feedback, of course. Well, I have a feeling that something's going on with my own because I have some kind of unhealthy health checks. That's interesting. Okay, let me see what we have here. Yeah, what about the service? Service is okay. One running infrastructure is here. No. What about metrics? All right. Mhm. What about our cloud formation stuff? Guys, let me know. Do we have pretty same the same stuff that I do? It looks like I'm having kind of a like issues here. So, how are you doing? Do we have the same as I do, or you have successfully uh, deployed uh, add-on like Q and updated your application manifest? How are you doing? It looks like you're having the same issue. This is interesting. Oh, cool. Great, Igor. So Igor, since you don't have this issue, you probably got to go ahead and continue on your own. But I think we will have to do some debugging probably and analyzing what's going on here. why we are having this issue. Well, wait a second. Did I do that? Wait a second. Actually, let me take a look. Oh, I can't take a look at this. All right. Yeah, well, sure. We do need to upgrade our manifest, but I have a feeling that maybe I was way too fast and I probably did not upgrade it. Okay, let me try to terminate the job. All right. Okay, let me copy and paste it here. And all right. And then try to do it all over again. Maybe it was because of this one. If we didn't, so just go ahead and do that. All right. Think it was my bad. I didn't insert it. Now I'll have to. Okay. All right. I need to wait for the stacks to be deleted and rerun it all over again. That was my bad. Sorry. Wasn't paying attention. Need to wait a little bit for the stacks to roll back. Stack actions. All right. Okay, let's wait. Okay, guys, for all of you who did not experience these problems, you can just go ahead and check the following steps. And you then get your load balancer URL and then try to send messages to your API. And then the results should be like this one. Then the next step, you got to go ahead into your AWS console and open your SQS service and see that there's got to be uh, more than 0 messages that were sent. Okay. All right. Are we still being deleted? Mm. All right, maybe. Okay, let me check. Uh, okay, Copilot. Help. Okay, maybe I'll be able to delete this. All right, help. Copilot. Oops. Okay, a little bit more of debugging, then less. What do we have here? Orders, all right. Orders API. Oh my God. All right. Okay, Copilot app. Name. There's just wondering if I will be able. Hmm. Okay. Where's my stack? It looks like it's still being deleted, but you guys, you go on with the following steps. You don't have to wait for me. And at each section, we have a challenge. Actually, if you got to this point, maybe you have some ideas how you can resolve these challenges, and maybe if you have ideas, you can uh, post your solutions into the chat, like just in a few words. All right. Okay. What do we have in the next step? All right. Oh, it looks like it's going to take forever. Uh, uh, Deletion is in progress. That is great, but sadly, it takes a while. So, oh, really? Let me take a look here. If deletion is complete, no. Okay, now we're waiting for the nested stack to be deleted. Okay. All right. So guys, uh, let me just talk a little bit about the next step here. So while my stack is being deleted, let's not keep silent and talk a little bit about our next steps. So here, we will be creating and activating SSM codes here. So uh, here we will be creating IAM roles, and the IAM role will be ECS role anywhere. And here we will assume the trusted policy. Actually, we can take a look at what this policy is. It's in the hybrid container, and there it goes. The trust policy. All it does is just allows this role to assume to assume roles actually, and we will be attaching two Amazon managed policies. This SSM managed instance core and Amazon EC2 container, et cetera, et cetera, et cetera. So this is an easy command. Go ahead and you create a role, assume trust policy, and I mean, yeah, then you attach one policy to the role and you attach another policy to the role. Then after that, you just go ahead and check if the two policies were uh, attached to our role. Well, the next step will be creating instance activation keys. These keys are needed for our EC2 instance, which will be on premise, yeah, to activate them and to bind this image to our ECS cluster. Okay, let me go back to my stack and check if we're good to go. Oh, we're almost there. We're almost there. Still in progress. All right. Well, things like that happen when you're not paying attention. All right. So this will be an activation code. So, uh, has any of you created an activation codes for ECS instance that will be deployed pretty soon? So, if you have, then you'll need to create uh, a Linux so-called on-premise service. I mean server. And to do that, we'll need to extract our VPC ID and our subnet ID. These are just simple commands. You can go ahead, copy and paste them. But then you will need to download a CloudFormation stack, a CloudFormation template file, and then create a CloudFormation stack. To this stack, you will be providing parameters like VPC ID, like this one, which will previously extracted from here, and a subnet ID. Well, as you run this command, it'll take some time, of course. A newly VPC EC2 instance will be created. All right. Okay, let me go back to my favorite cloud formation. And this delete is still. Oh, really? Can we go now? All right. Okay, let's go back and try it all over again. Yes, we probably need this one to run. Orders API is there, okay. Yep. And now let me double check about the manifest file just in case. All right, where is this? Orders API. Orders API Docker file. Orders Copilot. Orders API manifest. There it is. Let me. All right, I think it's here. Okay, let's give it another try. Go ahead and clear. Copy and paste. And there we go. Trying it all over again. So how are you guys doing? At what stage are you in right now? Just let me know, because I'm going to and I'm going to get you. All right. Let me take a look at the cluster, what we have here. All right, good. No services, no tasks. Cool. Let's wait for them to start. All right. Now, where am I now? Here. Container registry. By the way, there was a challenge for the container registry to what should you do to make it scanned at push? As you can see, we can go ahead and click on scan here, but we can go ahead and edit here and enable this one to scan on push. Or you can do it using, of course, you can do it using Copilot CLI as well when like when creating an application or an environment here. All right, great. What do we have here? I'm going to get you soon, guys. All right, Pavel. It certainly does a lot of time. Okay, but always you can go ahead and monitor your progress and like cloud formation, and you can take a look at your cluster if there are any changes here, new tasks or not. All right. Mm, okay, we can close something that's not required here. Okay, this one is not necessary. This one is not necessary either. All right. Yeah, you can grab some coffee while this is being created. Okay. Okay, I can close this one. Okay. So guys, at the Linux machine creating stage, were you able to successfully deploy this cloud formation stack uh, and have your EC2 instance run in here? Because when your cloud formation stack is completed, another so-called on-premise EC2 instance will be here in the instances running. All right, and and the next step will be to go ahead and retrieve private keys for your EC2 instance, and then open up a new console here. Yeah, a new console, and then use this command to navigate and log in into your on-premise EC2 instance. Yeah, and the next one, you'll have to run this command on your Cloud9 and copy and paste it over here, and then initialize ECS Anywhere in your on-premise EC2 instance. Well, those are pretty self-explanatory. So you run this command, then you create, configure your ECS on this external instance, and then you'll just go ahead and install ECS Anywhere on your like bare metal server, so called. All right. So I'm in progress so far too. Now let me see my cluster. Do I have anything here? Well, looks like that I do. Service is running, but the task is still pending. Okay. Well, actually, this is why it's pretty useful and convenient, I would say, to utilize cloud formation stacks. Because if something goes wrong, you made a mistake like I just did, you just go ahead and terminate the process, and the cloud formation stack will be automatically rolled back. It'll delete all the resources that were previously created by this cloud formation template. And so you then don't have to worry about and go ahead and search those resources that were created by this cloud formation stack and delete them manually, because well, maybe if you will have to start and recreate it, and maybe the same names will be applied, and then you'll get an error that this or that resource is already like it already exists, and you have to scratch your head what to do next and go ahead and delete something manually. So I do highly recommend using cloud formation in your practice, because it like well, it's pretty handy. You made a mistake, just stop the process, and everything is rolled back, and you can go ahead and start from scratch again. Oh, here we go. Uh, so my process is finally done. Hooray! That's great. Okay, let me go back where I was before I messed everything up. Okay. Okay, I did this, I did that, and now, okay, let's check this out. No, not the last, actually. Okay, now let's see the service, and there we go. It exists. That's great. Okay, now go ahead and extract the load balancer URL. We run this command, we copy and paste it. There you go. Now we do have it, and now we put it in our bash or C file. So when we open a new terminal next time, it will be there. And now let's go ahead and send some messages to the API and check. And there we go. Okay, guys, maybe you followed me and you made the same mistake, and you're having the same issue. Just let me know. Were you able to like delete the previous stack and redeploy uh, your application again? Just let me know in the chat. How are you doing? Okay. So our messages work perfectly. So we can go to our SQS service and check this out. Where can we go? Let's say here and SQS. Right. Okay, new tab. There it goes. And we have more messages than zero. By the way, we can like try it all over again. Maybe we can send another message, and maybe we can like, I don't know, 4 then go ahead and check it here. And now we have 3 messages. Great. It works. That's pretty nice. Okay. Exec in the task. It's pretty much the same that you'll be uh, like running a command inside your like Docker container. Let's try it. Let's see how it works. Copy and paste this command. Uh, say yes and wait a little. We'll install some plugins here. And there we go. I think we're inside the container. AWS. Yeah, there you go. Here it is. We are inside our container. We successfully ran a command. Okay, let's going next. So before we uh, create our so-called on-premise, yeah, great guys, nice. That's nice. That's true. Everything's working with you. Okay, so our next step is to create a role and attach a couple of policies to that role. Let's go ahead and not waste our time and create those roles. So first we attach this trust policy, then attach policy SSM managed instance core, and another one. Now let's go ahead and verify that we have done that completely correctly. There you go. We have 2 policies attached to our role. Good. Okay, what's next? Now we're going to create a system manager instance activation key. Well, this key is required for the so-called on-premise instance to get registered with our ECS Anywhere cluster. Okay, let's do that. So copy, paste, and here we have our activation ID and activation code. And just keep in mind and see this limitation. We're using the key, I mean, the flag registration limit 1. This means that we can register just one, whatever, an EC2 instance, a VMware virtual machine, or maybe your Vagrant machine that you're running locally, just only one. If you try it on another one, it'll fail. Right. Go ahead and click on next. So our next step is to create a Linux virtual machine. Well, it looks like it's pretty straightforward. First, we're going to extract our subnet and our VPC ID. This is pretty easy. Well, actually, if you're like interested, you can just take parts of the commands and see what's going on here. What it'll give it to you. There's a lot of information here, so you can learn it for yourself. What kind of information this command provides to you. And here you can see there's a filter. Looks like a JQ command. Okay, copy this, paste, and here we go. We have our subnet and subnet ID and our VPC ID. Great. So now it's time to create our virtual machine. For that, we just go ahead and download CloudFormation template and run it. All right. Excuse me. Oh, yeah. This command opens this in your Cloud9. Uh, what are you doing here? All right. This is not what I meant. Yeah, there it is. So you can go ahead and like take a look and familiarize yourself with this CloudFormation template, what kind of parameters we have here. As you can see, we have a subnet ID and VPC ID that we have to pass to this CloudFormation template before running it. Okay, and we're going to be doing so. All right. Go ahead and copy and paste this command. So you navigate to your environment hybrid containers directory. You'll use AWS CLI command to create a stack. We'll call the stack on-prem. The template body we just downloaded, and the parameters that will be passed for VPC ID and subnet ID we have just extracted by the previous commands. There. So let's go ahead and paste them and copy and paste them here. All right. And we can go ahead and verify that it's now in process. Yeah, there you go, on-prem stack, which the name we gave to it, and we can go ahead and open it and see what events are going on here and what resources it's creating. So it's creating an instance, a security group, a key pair, which will be extracting real soon. So now it's creating an instance, and we can take a look here in our EC2s. We go ahead and refresh our page, and there you go. Our on-prem EC2 instance is already running and being initialized. Okay, what do we have here? Yeah, and if we want to monitor our CloudFormation stack, we can do it from our CLI as well. We run this command. This is AWS CloudFormation and wait command. Yeah, and it will wait until this CloudFormation stack is created. All right. Think it's done, right? So quickly. Unbelievable. How could it be so fast? Let's refresh. Yeah, there it is. Great. All right. Now we have created our virtual machine. Perfect. Our next step is to create SSH private keys. As you remember, in our CloudFormation stack and the resource, this key was created, and probably we can, if we navigate here, let me see here, and probably we have key pairs here. Yeah, there it is, key pairs. Yeah, and there we go. Our key pair is here. Great, it's been created. So, so what should we do now? We retrieve the secret name, then we retrieve this and save SSH key with this command, and then we activate these IMDS stuff, kind of a metadata that you can get from your, if you like SSH to your server or SSM to your server, you can use like an API call from your with your curl command, and you can get some metadata information. So this command is just disables it. Okay, let's copy and paste this set of commands and run it. All right, it looks like that we ran this successfully. Now what we can do? All right, we can open our new terminal and run this command. So go ahead and open a new terminal and copy this command and try to open uh, to SSH to our newly built on-premise virtual machine. There we go. Here we are. So now we have two terminals open. We have our terminal on our like Cloud9 and our EC2 instance, or a virtual machine on premise. Our next step is to retrieve ECS external instance activation variables. Let's do that. Copy and paste these export strings, copy them, and paste into your Linux virtual machine and run it. Good. Okay, we have created our keys. We have created our VM. And now, well, it's time to install ECS Anywhere script on our virtual machine. So please don't confuse and don't install it to your Cloud9 ID EC2 instance. Install it to the on-premise virtual machine. So go ahead and copy this command, paste it into your terminal, and it'll take the script maybe a couple of minutes to run. And what it will do is just installs the script, does some configuration to ECS, and then we'll install ECS Anywhere. As you can see, the output is going to be like this one. Okay, guys. Now let me know, were you able to create a Linux virtual machine? Were you able to extract keys? I mean, the SSH keys, and log in to your virtual machine? Well, if you have done that, let me know. Just a second. All right. Okay. Let's see what we're going to be doing next. Okay, while it's, oh, there you go. So the ECS agent has been registered successfully to our virtual machine. And let's go ahead and check it from our Cloud9 instance. Run this command. And there you go. Everything looks good. Someone's writing to me. Okay. Oh, Anar, that's great. So the next challenge is here. So how much time? By the way, Anar, if you have finished module 1 and we have about probably um 20 minutes left, you can try module 2. Just if you feel confident you can do it, just go ahead, and so as not to waste your time, and maybe you can like play around with traffic uh, software. You can do it while we're just getting after you. So, what about this challenge, guys? uh, are you good? Are you good with Chef and Ansible? If you are, then this is your homework to write a bootstrap process to manage EC2 instances and with Ansible or maybe Chef, if you're good with them. All right. So what we do next? We will create an ECR repository and build our order process application, which we will run on our virtual machine on premises. All right. So here are some pretty simple steps. So we just go ahead and get logged in. Then we create a repository orders processor, right? Then we build our Docker container, and then we push our Docker container into the repository. That's everything is pretty simple and self-explanatory. All right. Okay. Now we're building our container, and after it's built, we will upload it. We'll push it to our repository, and we can go ahead and double check that. And repository. And let me take a look at the repositories here. And there you go. Orders processor repository has been created. Great. And what about there's no image so far? Okay, it's still being built. Yeah, it's now being pushed. And as soon as it's pushed, we can go ahead and double check it in our repository. All right. Can you configure container security on? Oh yeah, pretty much the same thing. Okay, our final push. So guys, tell me how are you doing? Hopefully you're not like having problems like I did, and you're just getting closer to the end of a module 1. So where are we? We're here. We want to take a look at our container repository and check if the image is here. And yes, it is. It's here. Again, if we want to scan and post, we can enable this switch and go ahead and save. Or we can just do the pretty same thing while creating the repository using AWS CLI tool. Well, this is easy. All right. What do we have next? All right, now it's time for us to deploy this orders processor application to our on-premise EC2 instance while orchestrating it by our ECS cluster. Okay, what we're going to be doing here is just creating a log group. Then again, we'll create uh, IAM policy from this document. You can familiarize it yourself here if you want to know a little bit more. Let's see our applications here, and you can check this. Yeah, is this the one? Task execution role. All right. Task is, oh, it will be created from the template. Yeah, there's the template, and for this template, we will create and assume a role policy to assume. All right. And there we go. Then what we're going to be doing next, we'll create a role, attach the policy. Again, we will create the task execution role, and again, we'll create a policy. Everything pretty self-explanatory. Okay. Go ahead and copy and paste this bunch of commands, and we'll be almost ready to go and register our ECS task definition. So it will be external task definition JSON. Yep. And we can see the parameters of our container here. And what else? Again, we'll be using SQS, and we'll be using AWS log. This is a log driver for a container, and we will be able to see our logs in our monitoring in in CloudWatch. So first of all, let's go ahead and create this file. Excuse me. Just wanted to do it step by step. First, we'll go ahead and navigate to the dairy. What the hell was that? Again. All right. I get it. I get it. All right. I'm there. Okay. Now I'm going to create. Oh, wow. This. No, it's not convenient because. All right. Let me try it like this. Oh, no. All right. Let me copy and paste it all in one bunch. Yeah, there we go. And here, this command, it registers our task definition. Okay, since we have registered our task definition, it is now time to run it. To run this task definition, we will run this command, run task, the cluster name, the launch type external, because we're using an external virtual machine for that. The task definition will be called order processor, like our application. Everything is like nice and easy. And luckily, we don't have any failures, which is great. All right. And if we want to check it, we can go ahead to our on-premise EC2 instance on a virtual machine and run this command, sudo docker or if this tab is not open with you, just go ahead and open it and run this command completely. But since my tab is already open and I've already logged in into our virtual machine, I'll run uh, this part of the command, which will show me what's going on. And there you go, our container logs here. Okay, now let's go ahead and check the status of our tasks. Okay, probably. Can we see our task in our cluster? And there you go. Our orders processor is here. All right. Okay, let me just stop it from here and check the status of the task. Copy this command and paste it over here. And there you go. No failures again. That means we have successfully done this. And again, we can check this stuff in the container. And there you go. We can see processing of our orders in the container. Okay, we can actually, the next step will be to send some more messages with SQS Q console and view the logs in CloudWatch. All right, but it's a bit more interesting to check with the script. We can go ahead and run the script from our Cloud9 EC2 instance. Let's go ahead and do that and see what will be going on. As you can see, it goes order 1,000, 10,000. Right. And let's see here. And there you go. We can see those like uh, orders processed, delete, and so forth and so on in our container. So the orders are processed successfully. So, guys, please let me know if you were able to get to this stage, uh, end-to-end flow test, and you're having the same result in your container. Just let me know in the chat and drop a plus or whatever. Maybe you have some issues or whatever. Just let us know. And so, what do we have next? Oh, that's almost the end of our module. Yeah. Also, we can go ahead and navigate to Container Insights and CloudWatch homepage and open our uh, Container Insights. Okay, let's go ahead and navigate there and check. Mm, What is that? CloudWatch homepage. Okay. Okay, let's take a look what we got here. Here we'll go to like on the left pane, find Insights, then go to Container Insights. Then choose ECS, all clusters, resources, performance monitoring. Yeah, then you choose performance monitoring and ECS cluster, the cluster. Yeah, do we have it? Oh, North Virginia. Oh, come on. If you got this and you see no cluster, you're probably in the wrong region. So got to go ahead and in the correct region, which is Frankfurt, EU Central 1. Yeah, and there you go. We have our cluster here up and running, and we can just monitor what's going on in our containers, the memory utilization, the network utilization, CPU, ephemeral storage, and other stuff. And service counts, so many services are running, and task counts. We have two tasks. One task is on like in our on-premise virtual machine. The other is here which is and all of them are managed by our ECS cluster. So guys, did you get to the stage already? Were you able to explore container insights? Just let me know. Okay, okay, and Anton, great. Maybe somebody else, because actually our workshop, well, it's coming to an end. We're not going to take module 2. So guys, maybe all right, all right. Uh, maybe someone has not yet finished, and then let me know in the chat, and we will wait for a little while. If everybody's finished, we will simply uh, finish our workshop as well. Everything seems to be working fine. So, all right. Since nobody's replying, guys, I would like to thank you for joining us. And hopefully, now you feel a little bit more confident with Elastic Container Service, and you got the idea how you can deploy your services, your applications using Copilot, and how convenient this tool is when you don't have to worry about your infrastructure where to deploy your application, right? And you probably got the idea. Hope you got the idea how Elastic Container Service Anywhere works, how it can manage containers not only in AWS but also somewhere on premises or somewhere else where the ECS agent is installed. All right. So that was the idea of today's workshop. So I'd like you to thank again for joining. Thank you for your attention, for your effort. This has been Sergey Konstantinov and EPAM and AWS support. And I would like to thank them as well. Oh, DJ Black, I'm so sorry. You should out Black. DJ Black, at what stage are you right now? All right. All right. All right. Maybe next time. Thank you, guys. Thanks for joining again, and hope to see you next time at our workshops. And happy learning. This has been Sergey Konstantinov. Bye bye.